Forward proxy, reverse proxy. Two words that sound like the same box pointed in opposite directions, and that's almost right, which is exactly why it stays confusing. Here's the honest reason. Both sit in the middle of a connection. Both speak HTTP. Both can hold certificates, terminate TLS, cache responses, rewrite headers. You can build both out of the same piece of software. So if the machinery is identical, the difference has to live somewhere else. In the next 10 minutes, you'll get a test that identifies either one in about 5 seconds, real examples of both, and the part nobody covers, what actually breaks when you don't have one.
Here's the whole idea, and everything after this is just detail. Every proxy works for somebody. A forward proxy is hired by the client. It stands in front of you, goes out and fetches on your behalf, and the server on the other end never learns you exist. It sees the proxy. A reverse proxy is hired by the server. It stands in front of the servers, takes requests from the internet, and the client never learns what's behind it. Forward hides clients from servers. Reverse hides servers from clients. That's it. Same box, opposite allegiance.
2 pictures, so this stops being abstract. A forward proxy is a hotel concierge. You walk to the desk and ask them to book a table. The restaurant takes a call from the hotel. They never hear your name. You had to know the desk was there and walk to it. And the concierge can refuse to book you certain places and remembers everything you ever asked for. A reverse proxy is the front desk of a large company. You dial one number. You have no idea who picks up or how many buildings they have. Reception routes you. You never learn anyone's extension.
So here's the 5-second test. Ask one question. Who had to be configured? If the client had to be told the box exists, a setting in your browser, an environment variable, a policy pushed to your laptop, it's a forward proxy. If nobody configured the client, because DNS simply points at the box, it's a reverse proxy. And if you want a second opinion, ask, if this box disappeared right now, who notices first? Clients lose their way out, or the internet loses its way in.
Concretely, what does a forward proxy look like on a real machine? Your company pushes a setting, a pack file, a group policy, or plain environment variables. http://proxy equals proxy.example.com, port 3128. Now, your browser stops resolving DNS and opening sockets to the destination itself. It opens one connection to the proxy, and in the request line, it writes out the entire URL, not just the path. It is not asking for a page anymore. It is asking someone else to go and get one. Where do you actually meet one? The corporate egress proxy is the classic. Every laptop's web traffic leaves through one box that blocks whole categories of sites and writes a log line for every request, which in a bank or a hospital isn't paranoia, it's a regulatory requirement. Schools and universities run the same thing under a friendlier name, a content filter. And at national scale, a country that inspects and blocks traffic is running an enormous forward proxy you never opted into, which is why the tools people use to get around it are themselves proxies. But you probably use forward proxies already without calling them that. A package registry mirror, Artifactory, Nexus, a Docker pull-through cache is a forward proxy for your build machines. They're configured to fetch through it. It caches the 400 megabyte image once instead of 100 times, and it can refuse a package nobody vetted. A CI runner routed through one fixed outbound address, so a partner can allow list exactly one IP, forward proxy. And when you point your phone at MITM proxy or Charles to see what your own app is sending, you have just installed a forward proxy, deliberately to spy on yourself. Which raises the obvious question, isn't that just a VPN? Same goal, different layer, and the difference matters. A forward proxy forwards requests. It speaks HTTP. It lives in a setting inside your browser or your tooling, and things that ignore that setting, some command line tools, some game clients, simply don't go through it. A VPN forwards packets. It rewrites your operating system's routing table, so everything leaves through the tunnel. HTTP, SSH, DNS, anything at all. Your machine effectively gets an address inside the remote network. A proxy is an errand runner that speaks your protocol. A VPN is a tunnel that doesn't care what you send. Now, how does a forward proxy handle HTTPS at all if the traffic is encrypted? There's a special move for that. The client sends connect, example.com, port 443,
and the proxy opens a raw TCP tunnel and relays bytes it genuinely cannot read, which means even with no decryption, it still sees a lot: which host you're talking to, at what time, how often, and how many bytes moved. What it cannot see is the path, the headers, or the body. And that line right there is what creates the next problem.
Because if you want to filter content and not just domain names, the proxy has to read inside the tunnel, and the only way to do that is to break it. Your employer installs its own certificate authority on your laptop. The proxy then generates a certificate on the fly for every site you visit, and your browser trusts them because the company told it to. That works. It also means one box decrypts every URL, header, and body for every employee. If that authority's private key ever leaks, whoever holds it can impersonate any website to your entire fleet. And apps that pin their certificates don't degrade. They just break.
So what happens if you don't have a forward proxy? For most people in most teams, genuinely nothing. That's worth saying plainly because it is the opposite of the reverse proxy answer. A forward proxy is a policy instrument, not a performance one. Without it, you lose central egress logging, category blocking, a shared download cache, and a stable outbound address that partners can allow list. What you gain is no choke point and nobody decrypting your traffic. Unless you're a regulated business or you carry a compliance obligation, not running one is a perfectly defensible default.
Now, flip sides. A reverse proxy on a real machine looks like this. The DNS record for your domain points at the proxy's address, not at your application. nginx listens on 443, holds the certificate, and hands each request to proxy_pass, http 127.0.0.1, port 8000. Your application binds to localhost only. It is not reachable from the internet at all. And notice, nobody configured a client. The client just resolved a name and connected, exactly as it would to any website, and never learned there was a hop.
Examples are everywhere once you can see it. nginx or caddy in front of a Django or fast API process, probably the most common web deployment on Earth. Cloudflare in front of your site, absorbing attacks and hiding your origin address. A Kubernetes ingress controller taking one address and routing by host name and path to a dozen services. A cloud load balancer in front of a target group. And the everyday one. /API goes to your node service. / goes to your static frontend, both on one domain with one certificate, which quietly deletes an entire category of CORS problems because to the browser, it is all one origin. The benefits you actually feel, roughly in the order they save you. One certificate renewed in one place instead of every service owning TLS. Many applications behind a single port 443 instead of one app per address. Rate limits, request size caps, and a web application firewall standing in front of code that has none of them. Static files served by software written to serve static files. And the underrated one, buffering. A phone on a bad connection, reading a response at 5 kilobytes per second, will hold one of your application workers hostage for a minute. The proxy takes that response instantly, frees the worker, and dribbles out on its own time.
Now the cost, and it bites almost everyone exactly once. Your application no longer sees the client. Every request arrives from one internal address, and the real one survives only inside a header, x_forwarded_for, that anybody can write. So there are two ways to get this wrong. Trust the header blindly, and an attacker sets it themselves and walks straight past your IP bands. Ignore it completely, and your per IP rate limiter now treats the entire internet as one visitor and throttles everyone at once. The fix is the same in every framework. Trust that header only when it arrived from your own proxy, and count the hops. Two more honest costs. It is a single point of failure. When the proxy dies, your site is down, while your application sits there perfectly healthy, answering on localhost, serving nobody. Make it redundant or accept that risk knowingly. And it is a configuration surface. Caching rules that don't account for logged-in users have served one person's account page to somebody else. That is a real and repeated class of incident. And when the proxy and the backend disagree about where one request ends and the next begins, you get request smuggling. And if you don't have a reverse proxy, here the answer is not nothing. Every service now terminates its own TLS and owns its own renewal, so a certificate expiring anywhere is an outage. Only one process can bind port 443,
So it's one application per address, or ugly port numbers in your URLs. Slow clients sit on your workers. Your framework serves static files at a fraction of the speed. Every backend address is public and scannable. You cannot add a second instance because nothing exists to spread traffic across them. And a deploy drops live connections because nobody is holding the door. One last thing, and it makes the whole distinction click. In a service mesh, every pod runs a sidecar, usually Envoy. Traffic leaving your application goes through it, that is a forward proxy. Traffic arriving at your application goes through it, that is a reverse proxy. Same binary, same config file, same container, two allegiances at once, which proves the point. It was never about the machinery. So, the test. Who had to be configured? The client? Forward. DNS? Reverse. If that landed, subscribe. The next one takes apart load balancers, which are reverse proxies that finally admit they have opinions.